Thank you, Dominika, for your introduction. Okay, welcome everybody. So I would like to, with the great pleasure, I would like to present hydrological studies of emerging pollutants in water and wastewater. So, ladies and gentlemen, we live on a human-dominated planet, putting unprecedented pressure on the system on Earth. 1 year ago, we surpassed the 8 billion people mark on Earth. Therefore, we can say that we live in the Anthropocene in a big world on a small planet. Here you can see that currently we have exceeded a few planetary boundaries, like, for example, geochemical flows, like land system change, biosphere integrity, and also climate change. Climate is especially important because we observe that the mean surface temperature on Earth is still increasing, and we observe also losing a billion tons of ice every year. Therefore, of course, the increasing temperature on Earth intensifies the global water cycle and significantly increase the frequency of extreme phenomena like floods, wildfires, and storms. So currently we know where water stress will be highest by 2040 and in which countries. Poland is in a special situation because we have big water resources. Of course, water quantity, but also water quality is important. And here you can see the map with the proportion of surface water bodies in less than good ecological status per river basin district. So we can say that European waters getting cleaner, but big challenges remain still. So therefore we need United Nations Sustainable Development Goals, and especially goals connected with biosphere. So goals like 15, 14, 6 and 13. This is important because this wedding cake is some roadmap for achieving sustainable and safe future. So we need transformative changes. We need innovation, solutions, new ideas, new paradigms, circular economy, hydrological biotechnology, and nature-based solutions. And important is to combine it with conventional infrastructure to improve benefits like water, like biodiversity, ecosystem services, resilience, and in our center, in the European Regional Center of the Polish Academy of Science, we try to develop some ecohydrological nature-based solutions which can be combined with conventional infrastructure. And example of this is multifunctional ecohydrological variant of reservoirs. These reservoirs are example of how we can develop some solutions, and reservoirs are important because lateral reservoirs are important because will be supplied with water during periods of good water quality in the river through the monitoring and regulator system, and we'll have biofiltration system of the inflow part of water to the reservoir. So lateral reservoirs are important because they can increase water retention in the river valley by rising groundwater level and restoring surrounding wetlands. This is especially important in the face of climate change. So we talk about water quantity, but also important is water quality. And in this point, we can say about emerging pollutants. There are substances that have been detected in the environment, emerging because they have become a focus of attention relatively recently as a result of advances in analytical techniques. And here we have also plastics, personal care products, antibiotics, and other pharmaceuticals, and also dioxins and PCBs. And now I would like to present some research results which we conducted in the Pilica River demonstration site of UNESCO. In my new project, we try with my team, we try to determine the transport of microplastic particles, pharmaceuticals, and antibiotic resistance bacteria and genes, and also nutrients from wastewater to the Pilica River catchment. At this Pilica River catchment, we have 17 monitoring stations and 8 riverine monitoring stations. So interesting is emerging pollutants and also microbiological contaminations, because they are ubiquitous and pose a new global challenge in terms of water quality. Maybe I try to start talk about first microplastics. So plastic are a broad category of synthetic or semi-synthetic materials that are used to manufacture a wide range of products, and you can see types of plastic materials like polyethylene, high-density polyethylene, polyvinyl, low-density polyethylene, polypropylene, polystyrene, and other. Interesting is that it is projected that the global cumulative production of plastics since 1950 will increase from 9.2 billion tons in 2017 to 34 billion tons by 2050. And interesting is that level of recycling, which is currently estimated to be less than 10%. So we have different types of plastic particles like macroplastic, mesoplastic, microplastic, and nanoplastic. And if we talk about microplastic, we have primary microplastics, so produced in small size, and secondary microplastic formed as a result of oxidation and decomposition of larger particles. And in this group of microplastic, we have pellet, fragment, foams, fibers, and films. So microplastic is dangerous because can accumulate in the liver and kidneys and brain and other parts of our tissues, and can activate T lymphocytes and can increase the risk of cancer. Therefore, here in my lab, we try to analyze microplastic concentration in water and wastewater. We use tear spectroscopy nucleate IN10 microscope thermo-scientific, and our preliminary results show that in treated wastewater we have microplastic particles, like you can see some fibers, foams, and so on. Also in the Pilica River water samples. Here you can see selected results, for example, for riverine water samples. And interesting was that we find ethylene, vinyl, and polyamide in the water, riverine water samples. So now I would like to go to antibiotics. Here you can see the consumption of antibiotics in the European Union in 2017, and for example, in our water samples, we also have antibiotics. So in the Pilica River and also in raw wastewater and treated wastewater, we have antibiotics, like you can see, and average concentration of antibiotics amount, like you can see here. But interesting was that the concentration, reduction of concentration between raw wastewater and treated wastewater amounts 68%. So also very interesting research are, like you can see, the aim of the study was to examine the quantity of antibiotic resistance genes in treated wastewater and the impact of treated wastewater to concentration on concentration of antibiotic resistance genes along the Pilica river continuum. And special our analysis show that in particular small wastewater treatment plants are one of the main sources of antibiotic resistant genes entering the environment. Another research showed that carbapenem resistance Acinetobacter, this is there are multi-drug resistance bacteria are present in the wastewater of all examined municipal treated treatment plants and in the majority of water samples from the Pilica river. In our center, in our research, we also try to quantify outflow of nutrients from wastewater treatment plants and also quantify of transport of biogenic compounds along the Pilica river continuum to the Vistula river, which is the biggest river in Poland. So we know that wastewater quality is not so good. Therefore, we try in our center, we try to develop some nature-based solutions for wastewater quality improvement. And here you can see an example of hybrid sequential sewage biofiltration system with good results, reduction of total phosphorus between 16 and 93% reduction of concentration, and for total nitrogen between 15 and 97% reduction. Here you can see most advanced sequential sedimentation biofiltration system for wastewater treatment plants in Szadek for removing particular nitrogen and phosphorus compounds, and to our analysis, we also try to use artificial neural networks for comprehensive analysis of catchment processes, because we know that the impact of anthropogenic sources of pollution on the water quality is so big, and this is very, very important for us, but this is big data, so therefore we try to use artificial neural networks also. And I would like to say that the Baltic Sea begins at the sources of rivers, has the quality of water flowing from river basins into the sea, so it's important for us water quality which are flowing from the Baltic Sea catchment. Here you can see key members of my research team, and in this point I would like to say thank you for everyone. And the research was conducted within the framework of the following projects, some selected publications, and thank you for your attention.